of you are there? Everyone is there?
No, ma'am.
Okay, it's okay. Then I'm going to start the class, okay? Slide so much. Okay. Do you know the topic of today's class? Do you know the topic? Okay, if you don't know, today's class is ovulation, fertilization, and implantation. It is written antibiotics. Is it so? But that is not correct. Today's class is ovulation, fertilization, and implantation. And before going to these topics, I like to talk a little bit about human embryology. Okay, it is ovulation, fertilization, all these are a part of human embryology. So what is human embryology? That you should understand. Human embryology is a science which study the processes and regulation of development of human fetus. I think you have already gone through the embryology of the embryology in biology. Okay, so this is human embryology. So it takes about 38 weeks from conception, and from pre-embryonic period, there are 3 phases. One is pre-embryonic period, that is first 2 weeks from conception, that is from the fertilization to the 2 weeks, and then embryonic period, that is 3 to 8 weeks, and perinatal stage 26 to birth. Okay, so these are the phases of human embryology. So now I'm going to talk about the ovulation. Ovulation is the process whereby a secondary oocyte is released from the ovary following rupture of the mature graphene follicles and become available for the conception. So ovulation is a process. It is a process in which secondary oocyte is released from the ovary, and that is after the rupture of mature graphene follicles, and it becomes available for the conception. It should be available for the conception. So from the ovary, the graphene follicles, mature graphene follicles, rupture of mature graphene follicles, and the ovum will be ready for the conception. That is ovulations. So before going to the ovulation process and everything, I like to talk a little bit about the gametogenesis. What is the gametogenesis? In human beings, gametogenesis is a little bit different from the animals or the plants. So gametogenesis is the process involved in the maturation of 2 highly specialized cells, spermatozoon in male and ovum in female, before they unite to form zygote. It is called gametogenesis. So before ovulation, there will be gametogenesis in male and female. So oogenesis is the gametogenesis of the female, and spermatogenesis is in male. So in females, at the end of 3rd week of gestation, there will be germ cells will migrate from the yolk sac, wall of the yolk sac, to the genital ridge, and at the end of the 4th week, it reaches the genital ridge, and these germ cells starts multiplying by mitosis, and these are called, these germ cell after mitotic division is called oogonia. And at the age of 20 weeks of gestation, there are about 7 million of oogonias, and some of the oogonia start meiotic division, and when they ends first meiotic when they ends in the prophase of meiotic division, when they completes the prophase of meiotic division, then it is called primary oocyte. At this time, some of the follicles will comes around the primary oocyte, and this continues up to the delivery, up to the puberty. So, and this at the time, and some of the primer and the oogonia stops, and birth about 2 lakhs primary oocyte will be there at the birth, and at the time of puberty, and it remains up to the puberty in decluttering stage. After completing the primary oocyte, at the time of birth, all the oogonia becomes primary oocytes, and these primary oocytes turn into decluttering state, and there will be no further division of meiosis, and it goes up to the puberty. And at the puberty, these follicle cells got maturated, and these are called maturation of the Graafian follicles. And there will be completion of the first meiotic division, occurs only after the ovulation. For the completion of the first meiotic division of this oocyte will occur only after the ovulation. And after this meiotic division, the oocyte contains 23 eggs, 23 chromosomes. Okay, so, and if after ovulation, if they are not fertilized, if they don't meet the sperms, then they will be degenerated. If they are fertilized, there will be further complication of the second meiotic. There will be completion of the second meiotic division, and the female pronucleus contains 23 eggs and the formation of another polar body. Okay, this is the oogenesis, that is the gametogenesis of the female. And in the male, spermatogenesis, germ cells goes into mitotic division and spermatogonia, and like that, they will form at the end spermatids. Okay, and these spermatids get morphological changes to the spermatozoa on their way up to the female genital organ, up to the fallopian tube. So, this is the gametogenesis. So, now I'm talking about the ovulation, mechanism of the ovulation. I think you all are hearing, okay? Yes?
Yes, ma'am.
Okay. So, are you understanding what I'm saying? Do you understand what
Yes,
I'm
ma'am.
saying? Okay. Then now, mechanism of ovulation. Mechanism of ovulation is first pre-ovulatory. There will be some changes, pre-ovulatory changes occurs in both the follicles surrounding the oocyte and the oocyte. Both of them will get some pre-ovulatory changes. So there is the changes in follicles that is surrounding the oocyte. What will happen to them? The pre-ovulatory enlargement of the Graafian follicles. These Graafian follicles starts increasing in size due to accumulation of the follicular fluid. And at the end, their size will be 20 millimeter in diameter. And the cumulus oophorus separates from the rest of the granular cells. In the Graafian follicles, there will be seen cumulus oophorus. This will separate from the rest of the granular cell and floats freely in the antrum. An inner layer of the cells surrounding the oocyte is called corona radiata. The inner layer of the cells surrounding the oocyte is corona radiata, and the follicular wall near the ovarian surface becomes thinner. The follicular walls near the ovarian surface becomes thinner and the stigma develops as a conical projection which penetrates the outer surface layer of the ovum. So there will be thinning of the ovarian surface and the stigma will project and and the cumulus escapes out of the follicles as a slow oozing process, taking about 1 to 2 minutes. Okay, so what that is changes in follicles. Now changes in oocyte. Significant changes in the oocyte occurs just prior to the ovulation, few hours. The cytoplasmic volume is increased along with the changes in the number and distribution of mitotic and Golgi apparatus. So cytoplasmic volume is increased and there will be some changes in number and distribution of mitochondria and Golgi apparatus. And completion of the arrestes, that meiotic division. At the time of the birth, there will be arrested meiotic division up to the decluttering phase, which is this phase is completed at the time of ovulation and occurs extraction of, and then there will be appearance of the first polar body and each containing haploid number of chromosomes. Okay, there you can see female pronucleus and the polar body. The difference between the polar body will be at the surface, which contains less chromosome than, less cytoplasm than the pronucleus. So the chromosome number will be similar, but the less cytoplasm. The polar body will be smaller. So what are the causes of the ovulation? Causes is endocrinal. Okay, there will be LS. Sustained peak level of estrogen takes place during pre-ovulatory phases. There will be sustained release of the estrogen, and the peak of estrogen release occurs 24 to 36 hours. And by this, there will be LS cells, luteinizing hormone cells, and after the 16 to 24 hours of luteinizing cells, there will be ovulation. And this LS cells also stimulate completion of reduction division of the oocyte and initiate luteinizing of granulosa cells and synthesis of progesterone and prostaglandin. So, and there will be FHS rise. The cause of ovulation is also, one is LS cells, another FHS during, because of rise on follicular stimulating hormone, pre-ovulatory rise of the progesterone. There will be rise of progesterone pre-ovulatory and positive feedback action of estrogen. This positive feedback action of estrogen cause FSH cells, which increase the plasminogen activator, which changes plasminogen into plasmin. This helps for the lysis wall of the follicle. Thus, combined LS and FSH mid-cycle cells is responsible for final stage of maturation and rupture of follicles and expulsion of oocytes. And there is some stretching factor also. Stretching factor is passive stretching that rise in intrafollicular pressure, which remains static at about 15 millimeter of mercury. Contraction of the micro muscles in the theca externa and ovarian stroma due to increased prostaglandin secretion. So what are the effects of ovulation? So by the ovulation, follicle is changed into corpus luteum. After the ovulation, these follicles, graphene follicles, these change into corpus luteum. And the ovum, which is ovulated, is picked up by the fallopian tube, and this may either degenerate or further maturation occurs. So this is the figure. This is the this is a follicle, okay, and then this is oocyte, and this is theca interna, theca externa. After the ovarian, this is oocyte, and after ovulation, it will be in second meiotic division will complete. And this after ovulation, this theca externa and theca interna, and this is follicular cells, and this all changes occurs. There will be change. Okay, this comes after. So in the this is nucleus of the oocyte, and after ovulation there will be first polar body is formation of first polar body. This is the zona pellucida, and this and this and granular outer side is granular cells. Now this is corona radiata covering the previtaline space. So this is ovulation. I think you understood ovulation. Did you? Do you understand ovulation? What I said? Yes? Hello, students?
Yes, ma'am.
Okay, you can read in DC data. Okay, obstetrics, it is all written. Everything is written here, there, so you can understand, you can read from that also. So now the second topic is my fertilization. Okay, fertilization is the process of fusion of the spermatozoon with the mature ovum. That is called fertilization. You have already read in biology also fertilization. Okay, so in human, if the fertilization is the process of fusion of the spermatozoon from the males and with the mature ovum from the female side. So what are the objectives of the fertilization? Why fertilization is necessary? To initiate the embryonic development of the egg and to restore the chromosome number of the species. What are the how many chromosomes are there in human species? Do you know? Okay, fertilization occurs in the ampullary part of the uterine tube. You should know that after the femoral end of the fallopian tube picking of the picked up the ovum, and that passes to the fallopian tube, and at the ampullary part of the uterine tube, if it meets with the spermatozoons, then fertilization takes place. Okay. So what are the things happens during fertilization? First, there will be approximation of the gametes, male and female gametes, and after that there will be contact and fusion of the gametes. So approximation of the gametes, after the ovulation, the ovum is picked up by the femoral end of the tube. Okay, that may be femoral muscular, that may be due to femoral muscular, or by the kind of suction or by the ciliary action that is present in the tube, or by the positive chemotaxis exerted by the tube. By this four process, the ovum is picked up, and fertilizable lifespan of oocyte ranges from 12 to 24 hours of the ovulation, whereas the sperm is 48 to 72 hours. So it takes only a few minutes for sperm to reach the fallopian tube. So this is approximation of the gametes. Now, contact and fusion of the gametes. Complete dissolution of the cells of the corona radiata. I have shown you the corona radiata. Complete dissolution of the cells of the corona radiata occurs by the chemical action of the hyaluronidase liberated from the acrosomal cap of the hundreds of sperm present at the site. When the ovum comes at the from ampullary part of the fallopian tube, if it meets sperms, okay, there will be hundreds of sperms present around the ovum, okay, and from the head of the spermatozoa, they will produce hyaluronidase, which liberated from the acrosomal cap of hundreds of sperms, and then there will be complete dissolution of the cells of the corona radiata. But penetration of the zona pellucida is facilitated by release of hyaluronidase from the acrosomal cap. Out of the many sperms, there are hundreds of sperms, only one touches the eloma and the zona reaction takes place. And after that, this eloma blocks. So only one sperm can enter through the zona pellucida. And the completion, at that time, there will be completion of the second meiotic division of the oocyte, and is containing haploid number of chromosomes, 23x. Okay, and there will be formation of the second polar body, which is pushed to the pre-uterine space. In this also, second polar body also contains a less quantity of cytoplasm, and the secondary oocyte contains the more quantity of cytoplasm. So this becomes pronucleus. So this is the figure where this is meiosis occurring in the chromosomes, and all the chromosomes, from the acromal end of the chromosome, they are producing the hyaluronidase. And then the lysis of the zona pellucida, and only one chromosome will enter into the cells. And after the division, and when this division completes in the female pronucleus, half of this chromosome, 23 chromosome, goes to the surface of the pre-uterine, and this becomes secondary polar oocyte. This is the primary polar body, and this first polar body, and this is second polar body. And this female, and this haploid chromosome of female pronucleus and male pronucleus, they will come together and becomes total number of the chromosomes. In human, both the head and tail of the spermatozoa enter the cytoplasm of the oocyte, but the plasma membrane is left behind the oocyte surface. Head and neck of the spermatozoa become male pronucleus containing haploid number of chromosomes, that is 23, that may be 23X or 23Y. The male and female pronuclei unite at the center with restoration of diploid number of chromosomes, that is 46, which is constant for the species, and the zygote thus formed. The sex of the child is determined by the pattern of the sex chromosome supplied by the spermatozoa. So sex is always dependent upon the male partner. So what happened at the end of the first week of post-conception? in the first week of first conception, zygote, when the male and female pronucleus unites, zygote is formed. And then after that, at the first week, the zygotes divide repeatedly, moving down towards the uterus. First into 2 cells, then 4 cells, then 8 cells, and these daughter cells are called the blastomeres. And morula, the solid cluster of 12 to 16 blastomeres, occurs at about 72 hours of fertilization. At day 4, 60 cell morula enters the uterus, taking off the fluid become blastocyst. So, excuse me. Hello? म क्लासमा छु अलिक पछि है क्लास ल ल ल ठिक छ sorry so this is a figure of fertilization. So ovary, after the ovulation, this femoral end will pick up this ovum. Okay, this ovum is picked up by four process, either by the femoral muscular cells, or by the chemotaxis, or by the cilia present in the tube, or by the chemotaxis, or maybe by the suction. This ovum enters into the fallopian tube, and this, when reaches up to the ampullary region of the tube, if it meets the sperms, then fertilization occurs. As I already told, what happens during fertilization. So after fertilizations, this one cell become 2 cell. This starts dividing, 2 cells, 4 cells, and then when it gets 16 cells, this becomes morula, and at the same time it enters to the uterus and forms blastocyst when it has 60 cells, and there will be cell mass. There will be cell mass at one side and single cellular covering the fluid. So this is blastocyst cavity, and this is blastomeres, and this is inner cell mass. This is called trophoblast, from which the placenta forms. So and after that, when the blastocyst is ready for implantation, so after this there will be the process of implantation. So blastocysts contain 2 distinct types of cell, that is inner cell mass, and trophoblast. This inner cell mass forms the embryo, and these trophoblast cells surrounding cavity, which helps to form placenta. And these floats for 3 days, and implantation occurs at the 6th post-conception. Trophoblasts erode the uterine wall. This trophoblast will erode the uterine wall and takes 1 week to complete. And the inner cell mass of a single blastocyst divides to monozygote identical twins if it divides at that time. This within 72 hours, there may be formation of the twin. So implantation, now after fertilization, implantation takes place. The process by which the blastocyst is embedded in endometrium. The process by which the blastocyst is embedded in endometrium is called implantation. It begins at 5th to 6th day of fertilization and completes at 11th to 12th day of fertilization, and it corresponds to 20th day of last menstrual period. So, implantation is the process by which blastocyst is embedded in endometrium, which starts at 5th to 6th day of fertilization and completes at 11th to 12th day, and it corresponds to 20 day of last menstrual period. There are 4 stages of implantation. So, first stage is there will be changes in blastocyst. The inner cell mass involved in adhesion to the endometrial cells. This endometrial cell mass involved in adhesion to the endometrial cells. And endometrium and there should be some changes in endometrium before the implantation. If there is no endometrial changes, implantation doesn't occur. The endometrium should be at secretory phase. And this trophectoderm interdigits in the secretory secretarial changes of the endometrium. And there should be uterine receptivity. Okay, there should be changes in the endometrium for implantation. The endometrium should be in secondary phase, and trophectoderm should interdigit, and there should be uterine receptibility, which is done by progesterone. And after that, there will be penetration. Stratum compactum vacuum is blastocyst penetrates into the endometrium, and there will be formation of stratum compactum, and then formation of vacuoles, and then these vacuoles is filled with blood, and that is called lacunae, and this enters into deeper stromal invasion and erodes an endothelium of the maternal capillaries. Okay, this penetrates, which erodes the endothelium of the maternal capillary, so the blood comes out from it and fills the vacuoles and called lacunae. And 4th stage in interstitial implantation, 13th day of fertilization. Interstitial implantation occurs at the 13th day of fertilization. So, process is zona pellucida disappears when the penetrates into the endometrium. The zona pellucida will disappear. Okay, zona pellucida and polar trophoblast toss the endometrium. As the polar trophoblast toss the endometrium, the zona pellucida will be disappeared, and it secretes the proteolytis, which dissolves the proteolytis is separated by corona radiata will dissolve, and there will be there will be a dissolve which will dissolve the endometrium, and this will embed into the endometrium. It will embed it into the endometrium, and there will be coagulation sealed in the space where it is embedded, coagulation sealed. So trophoblast become into 2 layers. Now this trophoblast, which is covering the blastocyst, becomes 2 layers. One is syncytotrophoblast and this inner one is syncytotrophoblast, and the outer one becomes the cytotrophoblast. Implantation usually occurs at the posterior wall of the fundus. This is fundus, and this occurs at the posterior wall of the fundus usually. And if implantation occurs other places, abnormal places like sometimes placenta, implant in the lower part of the, not in the fundus, but the below, by the cervix or lower uterine segments, then it is called placenta previa. And sometimes this may implant in the tube. Sometimes the due to less tubal mobilization or less movement of this zygote, they may implant into the fallopian tube, or sometimes they comes out and implant in the abdomen, or they may implant in the cervix. So these are called ectopic pregnancy. So the most common ectopic pregnancy is tubal pregnancy. So after the implantation, the endometrium of the uterus changes. After implantation, it decidualizes. So it is called decidua. And the decidua, which is at the base of this implantation, is called decidua bejalis. And the decidua which covers the embryo is called decidua capsularis. And the decidua which are around the uterine cavity away from the embryo is called decidua parietalis. Okay. What are the conditions for the implantation? There are some conditions for the implantation. For the implantation, endometrium should be at the secretory phase. If it is at proliferative stage, the implantation cannot be occur. So for IVF and all those things, we make the endometrium at the secretory phase before we entering the ovum. So fertilized ovum. So more or less should reach the cavity of uterus under time. It should reach the uterus, and gena pellucida should disappear in time. Hello? Okay, boy. एकछिन पठाउनु म क्लासमा छु 15 मिनेटपछि फोन गर्नु है. So there should be some condition for the endometrium, for the implantation. If this condition is not fulfilled, then implantation doesn't occur. For the implantation, endometrium should be at the secretory phase. Anyhow, it should be at the secretory phase. And morula should reach the cavity of the uterus on time. Morula should reach. If it cannot reach on time, then there may be chance of having ectopic pregnancy. The blastocyst may implant in the fallopian tube. So it must reach in the uterus at the time, on time. So, and another thing is zona pellucida should disappear in time. When the blastocyst touches the endometrium, it should disappear. If it doesn't disappear, then it cannot embed it inside the endometrium. So it should be disabled in time. So this is the implantation. So I have already talked about the ovulation, fertilization, and implantation. Now further development occurs. Okay. So second week, further development of the blastocyst and implantation. Okay. Inner cell mass divide into epiblast, and this inner cell mass divide into epiblast and hypoblast. Okay. And then later there will be a fluid sac. This fluid sac, this is amniotic fluid, and later this inner mass change into 3 layers: epiblast, mesoblast, and hypoblast. Okay. So, and there will be amniotic sac, and there will be yolk sac. Then these will turn over. So at the second week, bilaminar embryonic disc occur, and at the third week there will be trilaminar disc: ectoderm, endoderm, and mesoderm. Okay. Then these trilaminar changes into ectoderm, endoderm, and mesoderm, and then formation of the 3 germ layers. Endodome, mesodome, ectoderm, and then these tissues are formation by these different that you will cover by the embryology. Now I'm covering only the ovulation, fertilization, and implantation, and these are the things that happens in embryology. You have in your course or not, I don't know, but this is some that in some pictures I'm showing in the embryology. That is after second week of fertilization. So these are the embryological changes, and finally the major derivatives of the embryonic zone layers is formed by ectoderm, epiblast changes into ectoderm, mesoderm, and endoderm. And ectoderm will form the epidermis, hair, nails, brain, and spinal cord, neural crest, and epiblast and mesoderm will form these nodochord, somite, intermediate, and these will finally change into these dermatome, sclerotome, and with vertebra and skin and trunk of the limb and kidney, gonads are formed. And lateral mesodome, lateral plate may change into somatic mesodome, span, and these all the things. And the endodome will formation of the glands, digestive and respiratory tract. So these are all formed by the three layers of the embryonic zone layers. So today I'm covering only the implantation, ovulation, and fertilization. The rest, I think, there will be another class for you. Okay, thank you.